superstars, it's Mrs. Logan. I'm excited for our adventure this week. Here are some clues. See if you can guess where we're going today. If you guessed we were going to go exploring around Calavera Hills, you are right. Calavera Hills is located in Carlsbad, just north of Sage Creek High School and just east of Calavera Elementary and Middle Schools. Calavera has a lot of different hiking trails and biking trails, and there's many different kinds of plants and animals, and you can find lots of different wildflowers. There's a dam as well as a lake. And if you look closely in the middle of the preserve, you'll see this big, rugged-looking rock wall area. And the natives called this Calavera Hills, which in Spanish means Skull Hill. So I wanted to get a better look at this Skull Hill formation. And you might be surprised to what I found when I got there. Wait, it's a volcano? Right here in Carlsbad? Hello, my superstars. So today I am coming to you from Calavera Hills. It's right near Calavera Elementary and Sage Creek. So a place that you could easily come and take a hike in the next couple weeks. And it's also home to an extinct volcano right here behind me. This volcano is one of the smallest volcanoes that have erupted in North America. It cooled and hardened the lava inside the cauldron right here in the middle. And the pillars of rock that you see up here, those are called columnar joints. And when the lava at the middle of the volcano cooled, it contracted and split into 6-sided columns. So this volcano, geologists believe, erupted about 15 to 20 million years ago. I was so surprised. I mean, I can tell it's a hill, but I definitely didn't think it was tall enough to be a volcano. So this got me thinking, where do volcanoes come from? And here is what I learned. Below our feet, there are 4 different layers of our Earth. Let me show you. So I'm a super visual learner, which means I need to see things to really understand them. Oh, we got a surprise guest today. This is my kitty, Lego. Lego wants to be a part of our lesson today. All right, kiddo. There you go. So, the layers of the Earth. The inside of the Earth is made out of solid metal, solid. We call it the inner core. Oh, you can see I made a mess because I've been using Play-Doh and coloring Play-Doh. That inner core, the very center of the Earth, is about 4,000 miles below our feet. 4,000 miles to the center of the inner core. That inner core is as hot, scientists believe, as the surface of the sun. So between 9,000 and 13,000 degrees Fahrenheit. And because of this super high pressure and heat, it is not a liquid. It is believed that it is a solid metal. No one's ever been there, but that is their prediction from everything they know about metals and how they react under pressure and heat. All right, so inner core. Around that inner core, we have an outer core. From your feet, the outer core is about 3,000 miles straight down. That outer core is a liquid, kind of like molasses or honey. It's really slow moving metal. And the inner core, I'm going to put my outer core here, goes all the way around the inner core. of the Earth. And the inner core and the outer core, being made all of metal, are what create, they create the magnetic field that goes around our Earth. And we'll have to save magnetic fields for another lesson. We don't have time for that today, but nice to keep that in mind. All right, the next layer is the thickest layer of our Earth. It's called the mantle. And the mantle actually makes up, scientists believe, about 85% of the weight of the whole Earth. So it has a hard layer that's right up against the outer core, and then like a molten ooey gooey layer in between an outer core, an outer layer or hard layer on the outside of the mantle. I kind of like to think of it as like a grilled cheese sandwich. But this is what we call the rock cycle layer. This is where rocks are being made and rocks are being changed. They're changing from different types. You've got 3 types of rock: igneous rock, sedimentary rock, and metamorphic rock. And that's going to have to be for another lesson too. We have a lot to cover. But those 3 different kind of rocks change over time, and it can take hundreds of thousands of years, but rocks can actually change from one kind of rock into another, from a metamorphic rock into sedimentary rock, into metamorphic rock again, or into igneous rock. So this mantle layer goes all the way around the outer core of the Earth, thickest layer. Remember how I said that the core of the Earth was as hot as the surface of the sun? Well, that heat needs to escape, so it travels through the mantle layer out to the crust. But as it's doing that, it melts all this rock that makes up the mantle layer. Melted rock is called magma. Once magma reaches the surface of the Earth, we call it lava. Why does that magma have to come out of the mantle layer? Well, it's because of that pressure building up inside. I kind of like to think of it like a teenager having a pimple on their face. It eventually has to release and explodes. Then we have the top, the thinnest layer. It's anywhere from 5 to 25 miles thick. That's it. When you're talking about the center of the Earth being 4,000 miles below our feet, and the crust is only like 5 to 25 miles thick, that's super thin, kind of like the shell of an egg. So I'm going to put the crust of the Earth. The crust is our 4th layer of the Earth. All right, so let's look at what we've got here. We've got your inner core, outer core, mantle, and your crust. Now, what's on the outside of the crust? Our Earth does not look like this when we see pictures of it. No, our Earth is covered in vegetation. It's covered in land. It's covered in trees and shrubs. And it's also covered by, and mostly, what is it? Oceans, water. So here I'm going to put on our water so that our Play-Doh Earth looks a little bit more realistic. Okay, now let's take a good look at this. There we've got the outside of the Earth. And now we've got the inside. What are they again? Inner core, outer core, mantle, crust. So now that you understand that there's 4 layers of the Earth, does that explain to you why we have volcanoes? Probably not, right? We need to think a little more deeply about how the heat of the center of the Earth affects the rest of the world. The heat needs to be released, and so it's pushing out. And as that heat comes in contact with the crust, it needs to break through. Now, Luckily, the crust is not one solid layer. The crust is actually made up of a bunch of different plates, or I kind of like to think of them as pieces to a puzzle. Those pieces all connect around the earth and make up the crust. Here we can see those black lines. Those are all the outlines of each plate that surrounds our world. Now those plates are moving ever so slowly. Check out this short video to see how the heat from the core is driving or forcing the plates to move.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
Whoa, that was pretty cool. And the idea of an eruption right here in Carlsbad was pretty exciting, even if it was 15 million years ago. I started looking around during my hike to see if I could find different kinds of rock and signs of how the volcano had erupted. You know, not all volcanoes have a huge blasting eruption to release all that heat and pressure and gas and lava. Some volcanoes just slowly release gases and pressure that have built up in the mantle layer over time. All right, your challenge is to create something that can represent the different layers of the earth. So maybe you want to get some Play-Doh and use some food coloring and create a layers of the earth globe like I did. Or if you have some construction paper, you can draw circles and put in the different layers. If you just have paper and crayons or markers, you can draw your own inner, outer, mantle, crust picture. Share your layers of the earth creation on our flip grid at the end of this video. The second challenge is similar to the first, although I want you to be a little more creative in finding a way to represent the layers of the earth. Look at this amazing cake someone made, or these cookies. Or maybe you can organize rocks to look like layers of the earth. Look how this person made a cool and creative representation of the layers of the earth. Look how the inner core is made out of orange cupcakes, the outer core in pink, the mantle in the darker red, and the crust in brown. On the outside, you can see the oceans and vegetation. Your third challenge this week is to get outside and take a hike around Calavera Hills. You can learn a little bit about the watershed here and the wildlife. Maybe you can find the sign that shows all about how the dam was built in 1940. If you hike up to the very top of Mount Calavera, you can look down on the dam and Calavera Lake. That's where the volcano sign is down there, and the labyrinth or maze. What I did was I hiked over the bridge or the dam area And I took this path which parallels the shoreline and then up through the backside to the top. But there's lots of different hiking trails that you can explore. And once you're up there, you get a great view of the Pacific Ocean. You can see the high school, Sage Creek High School to the south. Maybe you can find the rock garden at the top, or the maze, which they call a labyrinth. Or you head just east of the volcano and you can go down around the boardwalk area. If you can't get to Calavera Hills, don't worry. Just go out, find a park or an open space near your house. Most importantly, you get outdoors, enjoy some time with your family or friends, and you take a good look around and observe your environment. All right, superstars, you have several different things you could upload to Flipgrid this week. You could show me your Play-Doh creation or a different way that you're representing the layers of the earth, or you could tell me about the hike you took and what you saw. If you made the Play-Doh layers of the earth, put it in a large Ziploc bag and save it for next week's lab. We're going to use them again and learn more about volcanoes. I'll see you next week.